I was thinking about that earlier today, actually.
Oh, you said I got on my dishwasher. That's what I thought you said.
I only wish that was true. Just kidding, Carter. All right. Refresh. Hit the restart button. Solving inequalities is just like solving equations, except that when you get to the multiplying and dividing step, which is always that last part, because you spend so much time distributing, combining like terms, adding, subtracting to move things around. When you finally get to that last step, which is the multiplying and dividing step, I put this in red here. You have to flip the inequality symbol when multiplying or dividing by a negative number. And so I've already filled this in because I forgot to start the video. So when multiplying or dividing an inequality by a negative number, the inequality becomes false. You must flip the inequality symbol. Here's what I mean by that. If I multiply 3 and negative 2 by 2 times 2 times 2. First of all, am I allowed to do that? Yeah. What you do to one side, you can do as long as you do it to the other side, right? What's 3 times 2?
6.
And what's 2 times 2? Okay. So 3 was bigger than 2. We agree with that. Is 6 bigger than 4?
Yes.
Okay, so we still agree with this. Now, on the other side of that line, I want you to multiply instead by negative 2. What's 3 times negative 2? Negative 6. It wasn't a trick question. What's 2 times negative 2?
Negative 4.
Negative 4. Do you still agree with the inequality? Negative 6 is bigger than negative 4.
No.
No. The inequality is now false. Negative 6 is not bigger than negative 4. Negative 6 is too smaller than negative 4. So in order to make this true, I would then have to be able to click the erase button, which I'm not able to do very well in this class, and then flip that symbol so it shows that negative 4 is actually the true larger number. I didn't have to do that when I multiplied by positive 2, but I do have to do it when I multiply by negative 2. I'm going to show you one more time. It's not just because, like, I don't need to look at this next example and say, oh, there's a negative, he's going to have to flip. That's not true. It's when you're multiplying or dividing by a negative. So this time we're going to multiply by 3, just because I feel like being different. What's negative 4 times 3? Negative 12. What's 5 times 3?
15.
Do you agree that 15 is larger than negative 12?
Yes.
Obviously. Okay, so I didn't have to flip that. I was timesing by positive 3. Now on the other side, I want you to times by negative 3. What was negative now becomes positive 12. And what was positive now becomes negative 15. And so if I don't flip the sign, I'm in trouble here because now I'm saying that negative 15 is larger than 12. So in order to make it true, I'd have to flip the inequality symbol. That's why we have to do what we do. Okay? Nobody made a rule to try to trick you and make you forget things. Like that's literally why we have to do it. Otherwise, the inequality, we'd be shading the wrong side of the number line. Okay? And I know you guys did some number line shading this week because everyone's turned in Friday's homework. It's like the first time that's happened this year where everybody has a homework assignment turn. It's actually the second time it's happened. Yeah, nice job. Nice job. Thank you for, I wouldn't say exceeding expectations. Thank you for meeting expectations.
You're welcome.
All right. So this homework assignment is a 7th grade homework assignment. These notes are 7th grade notes. Doesn't mean that we can't still have some complicated problems, but you're not going to have variables on both sides of the equation. You're not going to have answers that are infinitely many solutions or no solution because we didn't talk about that last year. So for first example, 5x minus 4 is greater than or equal to 11. What's the first thing I would do to solve this? Xander?
Add 4.
Add 4. Okay. I think we're past the part of me adding plus 4 and plus 4 to both sides. So when I do that, I get 5x is greater than or equal to 15. By the way, feel free to put plus 4. I have no problems with that at all. My next step is to do what, Martin? Perfect. What is 15 divided by 5? Okay. And we're not going to flip the inequality symbol because, Martin, what did you divide by again? a positive number. Yeah, so we don't need to flip. It's not every time, it's just sometimes. So I go down the number line. Chloe, would I put an open or closed circle around 3? Good. And is X bigger or smaller, Chloe? Bigger. Yep. I found that a lot of students who shade the wrong way have learned a trick that doesn't really always work. So the trick that they've learned is whenever the variable is written on the left side, the inequality symbol always points the direction that you should be shading. I don't know if you knew that or not. And most often the variable is written first. And that works until the variable is written on this side. And so people will purposefully flip it back around, but they'll not change the symbol when they do that. And then their shading's all wrong and their answer's wrong. So instead of trying to flip things around to meet your nice little trick, here's a different trick. Don't look at what direction the sign's pointing to. Instead, ask yourself, is the variable bigger or is it smaller? The variable's bigger because the sign's opening up towards the X. If it's bigger, shade to the right. If the sign's opening up away from the X, that means it's smaller, shade to the left. That's it. There's no trick. It doesn't matter what side of the inequality the X is written on. If the sign's opening up towards the X, shade to the right. If it's opening up away from the X, it means it's small, shade to the left. That's it. No fancy tricks. This next one. Jace, tell me the first thing I would do to both sides. Okay, so I'm going to subtract 4. When I write the b, the negative b over 3, I'm actually going to write it as b over negative 3, so I don't forget the negatives there. And then Jace, what is 13 minus 4? 9. Okay. And then Deegan, how do I get rid of the dividing? And what am I multiplying by? Okay. Oh, I said I wasn't going to write that down anymore, and then I did. When I multiply 9 times negative 3, what do I get, Deegan? Okay, what else happens when I multiply by negative 3? Brady? What else, Jacoby? That's what I was looking for. You flip the inequality symbol because we just divided by a negative. So maybe I should have put times by negative 3. Anytime you times or divide by a negative number, you have to flip the inequality symbol. So that's what I want you to write in that little blank right there. Flip. Just to remind yourself that you flipped that because you were timesing by a negative. All right. All right, let's go ahead and shade this in then. I want an opened or closed circle around negative 27. Lizzie? Open, good. And Lizzie, is B bigger or smaller? Excellent. So I'm going to shade to the right. The bigger numbers are always on the right side of the number line. And if it doesn't look so like that, it's probably because they're negative. And yes, they really are bigger. Negative 24 is bigger than negative 27. Example C. Christian, tell me what I should do to both sides. Perfect. What's 5 plus 7? 12. Okay. Jimmy, tell me what I should do now. Okay, so when I do that, remember when you do that, it's not like an equation where you can just put the variable on the left side willy-nilly and there's no problem. You actually have to move things around and switch the symbol. So let's do this first. Jimmy, what's 12 divided by 6? 2. You could write it like that, or if it really matters that much to you, you could flip it around. But when you flip it around, you have to make sure that the sign's still opening up towards the C. No matter how you write it, it should appear that C is larger than 2. If you rewrite it and you don't change the direction of the sign, now you're going to say that 2 is larger than C. So I'll accept either of those answers. I really don't need this answer in order to graph it. Some people, like, they can't graph it without answer. Now that's what I'm trying to tell you. Is C bigger or smaller than 2? Bigger, shade to the right. That's it. I don't need to rewrite it to try to figure that out. If C is bigger, I shade to the right. Now, am I going to do that with an open or closed circle? Open. Now, the reason I'm shading in the arrows as well is just because we know that when I shade a certain direction of the number line, it actually includes all the numbers up to positive infinity. and beyond, because there really is no end to numbers. And shading the other way would be negative infinity. So it's not, I'm not just saying that 3 is the only number that works here. I'm saying that any number larger than 2 works in all the decimals and fractions in between that you could possibly imagine. Example D. Deegan, what's the first thing I should do here? Okay. Deegan, what's 19 minus 4? Okay, what's left on the other side of the equation? Good. Yeah, don't forget that that's a -3. That would obviously throw things off for multiple reasons. Shane, what's our next step? Okay, and 2 things are going to happen when I divide by -3. What's one of those things? Perfect. -5. What else happens when I divide by a negative? That's right. So we get D is now less than or equal to -5. Maddox, do I use an open or closed circle? And is D bigger or smaller? Right, there we go. Connor, what's the first thing I should do for example E here? Good, and what's 9 minus 8? And what's left on the other side? Nice, I like how you automatically just put the negative down there with 3. All right. Chloe, what do I do now? Okay, what do I get when I multiply 1 by -3? And what else happens when I multiply by a negative? Perfect. Okay, so there, I flip the sign. Now, if you want to rewrite it with the variable back on the left side, you have to flip the sign again. Not something you have to do. I don't need this. I mean, I'll take it, but I don't need that. And you don't need it to graph. It's pretty obvious that I'm going to use an open circle around -3. Also, is E bigger or smaller? The sign's opening up away from the E. That means E is smaller, so I shade to the left. Yeah, I don't need the symbol to be, or the E to be on the left side in order for me to be able to graph. I hate seeing that as a teacher where students will they'll force themselves to rewrite it, and then sometimes they get it wrong, and so they miss a problem for no reason. Now, this next one is big fat fraction. BFFs, right? And so the first thing I should do, remember our steps. Clearing fractions is one of the things we can do at the very, very beginning of the problem. I can't actually add 5 to both sides until the 6 is gone, because the 5 is over that fraction, which I need to get rid of that fraction. So Garrett, what would be the opposite of dividing the entire side by 6? Perfect. Now, this is where we have to be careful, because we're not to that bottom step of our instructions where we have to solve for X and then flip the sign. But since Garrett just multiplied both sides by a number, even if we do that at the beginning, there's still a chance we have to flip the sign. Now, since Garrett multiplied by +6, we will not have to flip the sign, right? Okay, so Garrett, what is -18 times 6? What is -3 times 6? So we get F minus 5 is greater than or equal to -18. Seth, what do I do now? Okay, and Seth, when I add 5, I'll get F is greater than or equal to, good. So I'm going to put a closed circle around -13. And since F is bigger, I'm going to shade to the right. Ooh. G escalated quickly. It's another big fat fraction. Big fat fraction. I should still try to clear this fraction first. Oh, and how do I clear this fraction? By what? By what? by -3. Thank you. Timesing by -3 is the only way you can get rid of a dividing by -3. That's just going to leave us with -2j plus 5. So literally nothing happens on the left side. Just get rid of the fraction, get rid of the bottom part. On the right side, Owen, what's 7 times -3? Okay. What else? Sky? Yes, we have to flip the sign. Good job. We just divided both sides by a negative, so we have to flip the sign. And you know what? I don't want to peek ahead too far, but looks like I'm going to have to flip the sign back, aren't I? You see that there's a negative coefficient with our variable, so we have to get rid. Okay, so we'll do that here in a second. So we're flipping the sign once. I'm going to highlight it. We're flipping the sign there. And then we're going to do what, Oliver? What's my next step? Okay, so when I subtract 5 from -21, that's going to give me 26. Okay. And then Dawson, how do I finish this? And so when I divide by -2 on both sides, two things are going to happen. Sign flips again back to how it was originally, and you get 13. That's right, positive 13. Nothing you guys haven't seen before here. Jacoby, what should I do first for this one? Distribute? Okay. What do you get when you distribute? Perfect. Now, by the way, even though we are multiplying by a negative, we're only simplifying one side. We're not actually multiplying both sides by a negative. So this is perfectly fine. You don't need to flip the sign here. We will flip it here in a moment to get rid of the -2. Jimmy, what's my next step? Okay, Jimmy, if I subtract by 10, that leaves me with -2h. And what on the left side of the equation? -4. And then Lucy, I need to finish this by doing what? Perfect. Lucy, when I divide by -2, I flip the sign, good. And you get +2. Excellent. Oh, I didn't graph either one of these last two, so I need to graph them both. I left myself a ton of space. You know why? Because I was still, when I was doing these, I was still writing in between steps, which are still perfectly fine to show. But at bare minimum, you'd have to show what I'm showing. There's no way you can solve example H with any less than 3 lines. Unless you took the shortcut that we talked about last chapter. Do you remember what the shortcut is? Deegan, what's the shortcut?
You divide by -2 on both sides.
Yes, you could have divided by -2 on both sides, which by the way, you would have to flip the sign there, wouldn't you? You just did it to both sides. That would give you -3 is now less than h minus 5, and then you would add 5 to get 2. You get the same answer. So you could do it in less steps. All right, so I'm going to use an open circle around 13. Whoa, that's the eraser. Open circle around 13. I'm going to shade to the left. I'm going to use an open circle around 2, and I'm going to shade to the right. That is because in example G, the J, why did I use J when it's a G? I used all the other ones. That's stupid. I shaded to the left because J was small. But in the next example, the variable is bigger, so I shade to the right. I'm burning up in here. I'm sorry. It's really hot in this room. I need to, like, every other room I feel like it's much colder. I need to start wearing shorts or something. I don't know. I'm just really hot.
Short break time.
The window's open. The window's open. So, okay. It would be. A contestant in a weight loss competition wants to lose an average of at least 8 pounds per month during a 5-month period. How many pounds must the contestant lose in the 5th month to meet that goal? Contestant wants to lose an average of at least 8 pounds a month during the 5-month period. You can see the chart here has their weight loss for the first 4 months. What's unknown to us? Xander?
The 5th month.
The 5th month. So I know that when I'm doing an average, and we had one like this on our test that we took Friday, there was an average problem with points, I believe, or something like that. So this one, you would have to add up all 5 numbers and divide by 5. Well, I don't know the 5th number. So what I can do is I can add up the 4th numbers. We can call the 5th month M, and then we can divide that by 5. So what do you get when you add together the 12, the 9, the 5, and the 8? Xander?
34.
34. Okay. So far we've already lost 34 pounds. Plus we're going to lose more pounds in the 5th month. So plus whatever we lose in the 5th month, all divided by 5. It's one way you could simplify it. So it's already, instead of adding all the numbers and then have to simplify, just do that right out of the gate. 34 plus M divided by 5. And then it says lose at least 8 pounds. How do I write that I want to lose at least 8 pounds, Shane? That's right. Is greater than or equal to 8. The phrase at least means that 8 is the minimum I want to lose. Would I be okay if I lost more than that? Yes. So you can lose greater or equal to 8. You just don't want to lose any less than that. So when it says at least, that implies that there's a minimum value, and anything higher than that's still okay. So greater than or equal to. So now to solve this big fat fraction, I got to clear my fraction by timesing by 5. Sky, when I times by 5, do I have to flip the sign? No. Emerson, what do I have to do to get rid of the 34? Okay, what's 40 minus 34? And then what were we talking about here? Were we talking pounds? Yes. And the abbreviation for pounds, we don't want to write the whole word out, is LBS. So as long as you lose 6 or more pounds, greater than or equal to 6 pounds, you'll have reached your goal. Yes.
Why is it LBS? Well, there's no L or B.
I don't know. I'm going to guess it has something with its Latin root. I'd have to guess.
Why does everything come from Latin?
Because that was originally the language. I mean, everybody spoke some form of Greek or Latin. So, all right, there's more to it though. There's some more problems. And I put this nice little chart on here because you probably are going to see more questions that have phrases like at least, like this one does right here. So now you have somewhere in your notes where you could go and actually look at that. And so I don't think anyone's going to have an issue if I use the word fewer than to replace less than, or if I use the phrase more than to replace greater than. Where the issue seems to come is when we use phrases at most, no more than, at least, no less than. When I use the phrase at most or no more than, that implies there's a maximum and that I don't want to exceed that. I can have at most 4 people in my car. I can't have any more than that. This won't work. It'll be illegal. We'll be driving down the highway, get pulled over, and get a ticket. Okay, so I can have less than that. I can have 4 or less, but I can't have any more than. So this implies that I would have to have less than or equal to. So there's a maximum, and anything lower than that or equal to works. If I use phrases like at least or no less than, that implies there's a minimum. I need at least a 90% to get an A. I need at least $20 to go shopping. Okay, that implies there's a minimum, and I'll accept anything greater than that or equal. So greater than or equal to is the what I want to use if I see phrases like at least or less than. And you can see why people get confused. It's got the word least and less, and we're using a greater than symbol or equal to. It's got words most and no, well, it says no more, so that's pretty obvious. It says most and more, and so we use a less than symbol. And so it can be a little confusing. I get that. You have to think logically about it. This is like the last activity we did from last chapter. You want to find the values of x so that the area of the rectangle is more than 22 square units. How do I represent the area of that rectangle? Jimmy? Yep, and what would I plug in for those? And then Jimmy, it says is more than, so what symbol? Nope, it just says more than. So just greater than 22. I'm not even gonna have you guys solve it because we just did a bunch of solving. So we'll just write these and we'll move on. Now he tells me, shouldn't have worked ahead. You want to find the values of x so that the perimeter of the rectangle is greater than or equal to 28. How do I write the perimeter of that rectangle? What expression could I use? Xander?
2 in parentheses x plus 3 and parentheses plus 8.
Okay. And then it says is greater than or equal to. So,
Oh, yes. That's greater than 8.
okay. And then what?
28.
28. That's one way you could do it. He doubled the length, he doubled the width, right? You could also write it like this. Where'd the 7 come from? Shane, where'd 7 come from? Yeah, you could add 2 sides together. X plus 3 plus 4 is x plus 7, and then double that, and that would be effectively the same as doubling the length and width. So a couple different ways you could write that one. Either way, that one works. And of course, we'd have a ton of simplifying, and then we could solve that, but we'll do that later, or not at all. C, you want to find the values of y, so the area of this parallelogram is fewer than 41. Seth, what would I do to find the area of a parallelogram? Okay, so what's my base and what's my height? Okay, it says fewer than. Seth, what symbol should I use? All right, less than 41. Example D, it's a trapezoid. You want to find the values of Z so that the area of the trapezoid is at most 100 square units. Maddox, how do I find the area of this trapezoid? That's right. Okay, so let's plug in. What's base 1? Z plus 6, okay. What's base 2? Just Z, good job. It's bad looking Z. I should probably lower my font. Oh my gosh. I'm gonna lose it. I'm gonna lose it. Okay. So I've got 1/2 Z plus Z plus 6, or 2Z plus 6 times the height. What's the height, Maddox? 10. And then it says is at most 100. It's at most 100. Does that imply a minimum or maximum? A maximum. So if it's maxed out at 100, it could be 100 or less. So less than or equal to. Good. Less than or equal to 100. And I'm going to tidy this up a little bit because I know we could leave it like this, but I'd almost rather just get rid of the 1/2 and the 10 and call that 5. Parentheses 2Z plus 6. It just looks a lot nicer that way. You want to find the values of X, the volume of this prism is at least 50. How do I find the volume of a rectangular prism? Lizzie? Okay, so the length and the width, 5 times 3 gives us, okay, so I got 15 times the height, which is X plus 2. That represents the volume, and that has to be at least 50. If it says at least 50, does that imply a minimum or maximum? Shane? A minimum, so it's going to be 50 or Greater, so greater than or equal to, good. And then the last one, right as the bell's getting ready to ring. You want to find the values of x, so the volume is, oh, it's still volume. That's easy. Still volume. So 4, what's 4 times 4.5? Shane? 18. So we have 18 times then the width there, which is 2x plus 1. And that has to be no more than 36. So if it says no more than 36, does that imply a minimum or maximum? No more than 36, no bigger. So it's a maximum. So if it's a maximum, I want 36 or less than. So less than or equal to.
I wrote that down. I just didn't say it.
All right, that's well, the homework's 7th grade 4.4. It's on big ideas. You need a work paper for it, and it's due Thursday. See you guys later. Do definitely do.